What challenges grid stability in global power systems? Imagine a world where electricity flows smoothly, powering everything from your morning coffee to massive factories. Now picture what happens when that flow gets disrupted. That's what grid stability is all about. It's the backbone of reliable power systems worldwide. But keeping the grid steady isn't simple, especially as we add more renewable energy sources like wind and solar. These sources are great for the environment, but they also introduce new challenges. One big issue is grid inertia. Traditional power plants like coal, natural gas, and hydroelectric dams have large spinning turbines that act as a buffer against sudden changes. They resist quick frequency shifts, helping keep the system stable. But renewable sources like wind turbines and solar panels use power electronics instead of spinning machines. This means less inertia in the system, making it easier for frequency to fluctuate rapidly during disturbances. Faster frequency changes can lead to blackouts if not managed properly. Another challenge is controlling the frequency and voltage. Power systems need to stay at a specific frequency, usually 50 Hz in most countries or 60 Hz elsewhere. When renewable energy output varies due to weather, it becomes harder to keep these parameters within safe limits. Fluctuations can cause power quality problems and even cause parts of the grid to disconnect to protect themselves. Balancing supply and demand is also tricky. Renewable energy depends on weather conditions, which are unpredictable. If wind suddenly drops or the sun sets, power generation dips. Without quick adjustments, this imbalance can cause frequency swings or voltage drops. To prevent this, grid operators use advanced forecasting, real-time monitoring, and fast-responding control systems. Transmission lines face their own set of problems. Long-distance power transfer causes energy losses because of resistance in the wires. Aging infrastructure and limited capacity of existing lines make it harder to move renewable energy from where it's generated to where it's needed. These constraints can cause bottlenecks, reducing overall system stability. Operational complexity increases as well. Fluctuations in power flow and voltage put mechanical stress on equipment like turbines and transformers. Over time, this stress can shorten equipment lifespan and increase maintenance costs. Managing these dynamic conditions requires sophisticated control systems and modernized infrastructure. To tackle these issues, engineers are working on smarter grids. These include decentralized energy production, where power is generated close to where it's used, and advanced monitoring systems that give real-time data. Technologies like synchronous condensers and static synchronous compensators can provide synthetic inertia and voltage support, helping to fill the gap left by traditional turbines. In essence, the main challenges to grid stability come from the reduced inertia caused by renewable energy, the variability of renewable power, transmission limitations, and the need to keep frequency and voltage within safe ranges. Solutions involve upgrading infrastructure, implementing smarter control systems, and integrating energy storage. These steps help ensure that our power systems stay reliable, even as they become greener and more complex.